Welcome back. So we are going to continue with the reactivity series in this module, and this screencast is basically going to give you a summary of all the experiments, or otherwise known as practical sort of elements to this theory on reactions. And yeah, it's a very common thing to ask in exams. They'll give you a picture of a reaction, they'll give you a picture of, I don't know, a beaker or a polystyrene cup with a thermometer inside of it, and they're going to ask you a whole bunch of questions on it. So let's go through the reactions, go through them yourselves, redraw them, really know all the names of the equipment, know all of the reactions, know all of the reactants, know all of the products. Okay, let's get straight into this. Okay, so the first reaction, or the first concept that we really need to talk about is the reactions with calcium and water. So this is a metal that's found in our reactivity series. Now, if you have a look at the reactivity series, this little series of elements, we can highlight a few concepts here, or a few elements. So we've got hydrogen. This is what is found in water. Okay, we can see calcium is above hydrogen. If there is a metal that is above hydrogen, it is going to react. So what's going to happen here? We've got calcium, so you can kind of call this calcium granules. We've got our beaker. We've got a funnel here, it's upside down. And then we've got a boiling tube that's on the top of the funnel, boiling tube. Sometimes called a test tube, boiling tube. Okay, so what's going to happen here is we've got the calcium, Ca, don't forget to put the state, it's a solid, plus water, which is a liquid, and this is going to give us hydrogen gas. Okay, so these little bubbles that are popping off the top here, pop, 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 are hydrogen gas. So what's happening is this metal and this water are reacting, and it's going to actually form hydrogen gas. But if you think about this, what else are we going to form? If this hydrogen came off, what's going to happen between this calcium and this oxygen? That's quite right, they're going to form a metal hydroxide. So calcium hydroxide is formed, and this is in solution, so we can say aqueous. Okay, one other thing to note is that it becomes warm. So if you had to sort of hold your hand on the beaker, you would start to feel a temperature increase. So you can say it becomes warm. So this is your first reaction. Now what you could do is you could take this boiling tube over here, and you could sort of lift it up, put your thumb on the bottom of it, and the hydrogen gas bubbles, obviously they're see-through, so you wouldn't be able to see them, but they would be sitting at the top of this boiling tube. And what you could do then, let's go to the other camera, you could then take that boiling tube. Okay, I've got a little coffee mug here, let's take the coffee mug as the boiling tube, and as the hydrogen bubbles start to sort of rise up and join up with the atmosphere, you could light those hydrogen bubbles, and what you'd get is you'd get not an explosion, but you'd get this little popping sound. It'll go like, and if you can hear that there's like a popping sound, then it proves that it's hydrogen, because hydrogen makes a popping sound when it is lit. So that's a test for hydrogen. It makes a popping sound, and yeah, it's quite fun to do. Okay, let's go to the very next reaction. So this reaction is with magnesium and steam. So if you had to put magnesium into water, just sort of normal cold water, it would react very slowly. It wouldn't really react. So what we can do is we can put some water sort of soaked into like a little sponge here, like, I don't know what we're going to call it. Let's just say water soaked. Okay, then we've got our magnesium ribbon over here, which we put into the middle of a boiling tube. And then what we've got here is sort of like a delivery tube, they call it, that's in between sort of what this is called a rubber stopper. Okay, so what we do is we apply some heat here. So we don't directly apply heat to the water soaked area, just to the right of it, and enough of the heat will transfer across. So let's just say heat. It'll transfer across to the water, and the water will start turning into steam. And as the steam starts to move to the right, it's going to then react with the magnesium. So again, we've got magnesium, which is a solid. It's reacting with water at this point, and the water, we can say, let's just keep it as a liquid, even though it is a gas. It's reacting as a gas, and this time it's going to make magnesium oxide. Now magnesium oxide is also a solid. It's a white powder, so you're going to start to develop a little white powder at the bottom. And don't forget, if you think about magnesium has joined up with this oxygen, what else are you going to make? You're going to make hydrogen as a gas. And again, you could put a little flame over here from a Bunsen burner or something like that, and you would get this popping sound from the hydrogen. So that is another reaction with magnesium steam. Let's see if magnesium is above hydrogen on the reactivity series, and it is. And this proves again that if it is above hydrogen, it is going to react, and it's going to form a metal oxide, as we can see here, and hydrogen. Okay, let's go on to our last experiment. This time we are dealing with a powdered metal. So this is powdered. Oh, I think I spelled that wrong. Powdered. Yeah, it should be powdered. Anyway, let's take it out. Let's get everything right. Come on, people. Powdered metal. So you can use zinc or iron. Yeah, zinc or iron. And we got water soaked in this section. Water soaked. We're going to apply some heat directly over here. And what's going to happen is the steam's going to come across, and it's going to join up with either the zinc or the iron, and it's going to react. Now what we've got here is a delivery tube where the hydrogen that's going to come off of here, so little H2 diatomic molecules, they are going to travel down this delivery tube all the way down, and you're going to start to see these bubbles develop into a boiling tube. So this is a delivery tube, and obviously you guys know the rest. Again, you could then remove this boiling tube and light it, and it would make a popping sound. Let's just quickly do the reaction. So we've got, let's use zinc, and this is going to react with water. I'm going to balance this equation in a second. So this is water as a liquid, and this makes zinc oxide, which is a solid, plus H2 gas. Now if you had to quickly balance this equation, let's think about it. We've got 1 on zinc on the side, 1 on the right, 2H2. It's actually balanced perfectly. Wonderful. So if you had to use iron, it would be a different equation, but very, very similar. So we get iron solid plus water liquid. This is going to form iron oxide. What color is iron oxide, everyone? Come on, you can tell me that one. All right, let's see if this is balanced. This is not balanced. We're going to put 3 ions on this side because iron oxide is actually like this. Yeah, that's fine. And then we've got 4 hydrogens on this side and 4 H2. That's the balanced equation. Remember, if we had to look at our reactivity series, let's look for iron and let's look for zinc. So iron's over there, zinc, they're both above hydrogen, and this is important. Now the reason why I'm not sure why these two are highlighted, but if you had to take copper and you had to react copper in this equation, so say for example we used copper here, okay, and not zinc and iron, what would happen if we used copper instead of iron and zinc? Look where copper is on this table. It's below hydrogen, right? So if you took copper, the solid, and you combine it with water as a liquid, there would actually, nothing would happen. Okay, so you can write here, there wouldn't be any products formed, nothing would happen. And this is the experiments you need to know. Let's go back to my camera. How's it? These are the experiments you need to know for reactivity series. So far, this is part 1. We're going to do part 2. This was the reactions with water, so a lot of metals. Now we're going to do in part 2 the reactions with acids. It's going to be really interesting. See you there.